Hi, this is Sudeep Panchanda from Quite Easily Done. This video series is Know Your Boards, which is dedicated towards understanding the boards that we would be using in our projects. The boards simplify how we build our projects without having to go into the detail of concepts and the working of each of the components. They just become building blocks for us. But for us to be a better engineer, for us to be able to explore what all we can do and be able to unleash our imaginations, it is always good for us to know how these boards work. The board that we will be talking of today is a relay board. In the electronic world, the digital world, we talk of binary signals, which is zeros and ones or high and low. We said 0 or the low signal represents an off state. A high or a 1 signal represents an on state. Now that has to be practically translated towards switching on and off of appliances like this LED bulb over here. We looked at in the Know Your Component series about components like this small component, the transistor, which can be used as a switch. So the base was where we were giving this digital signal, and we were able to use it as a switch to switch on or off a particular circuit. Practically, when we are trying to switch on and off an electrical appliance which is running on 220 volts AC, we would not want to put in that entire load on this small transistor over here. Two reasons for that. One, the transistor might not be able to handle the amount of current flow that this appliance would demand for. Second, we also want a level of electrical isolation between the controlling circuit and the appliance itself. Now let's say instead of this LED bulb, I had something else which was much more complex and can have short circuit within it. I would not want my complex electronic circuit to fry just because there was a short circuit in the controlled appliance. So to isolate them and to be able to control appliances which require higher voltages and currents, we use something called a relay. A relay is an electric coil. It has an electric coil in it, which and a metallic strip, which helps in switching on and off a circuit based on if you have given a voltage to the coil inside it or not. We will look at that in detail right now. So based on this concept of the relay, we have created a relay board which just helps us work with electrical appliances and do a prototyping and testing of our concept in a much more safer and convenient manner. So let's have a close look at this board right now. So this is the close look of the relay board. We have is the input over here and the output. So let's say we are controlling the LED bulb that we were looking at. So this would be the 220 volts AC input to the board, which I would be connecting it to the wall socket. This is the output, which means 220 volt output, which I would be connecting to the appliance. And we have a transistor, in this case BC547, and we have the relay. Now we have over here is a 12 volt supply input, which we would be feeding in through an adapter, and in case we have a strip adapter like the one that we use for the LED strip lights, we can connect it using the AC pins over here and give the input 12 volt input over here. The left one is the ground pin and the right one is the plus 12. This is the input, which is the digital input for us to work with. This might be an input which might be coming in from different sensors that we would be working with, and the one below it is a 3.3 volt supply, and the below it is a 5 volt supply. We would be using these supply voltages to power in our sensors. It just makes life convenient for us in the sense that we don't need multiple adapters to work with, and we get the supply also from here for the sensors. We're able to put in the input also and very conveniently connect the appliances over here. So let's look at the working of this, how it works. a demo of it, and let's see how is it different from the boards that we see in the market, the ones that we purchase. Why is it much more convenient and safe? So I have the relay board wired up right now. The bottommost pin over here is connected to the 12-volt power supply. As I said, the right one is the positive, the left one is the negative. My output has been connected to the LED bulb. What I've done is I've connected the LED bulb to the NO portion, which means when I give in a positive signal, it is the relay would switch on the appliance. If I connect the LED bulb to the center pin over here, it will be switched off when I give a positive one or a high signal at the input over here, the input pin. I'll show you that in a minute. So I'm connecting the 5-volt output of the relay board to the input of the relay board, just to simulate a scenario where I'm getting a +1 from, or a logic high from the sensors. It might be a proximity sensor which has detected something in its proximity, or a motion detector sensor which has detected motion. It might give a logic 1 or a +5 volts output to the relay board, which becomes its input, and when that input comes, our appliance gets switched on. When I remove it, which is like being 0 volts or a logic 0, the appliance gets switched off. So the relay board helps us in controlling the electrical appliances using just a 5-volt controlling signal. In this case, the relay board also provides us with the power supplies for the sensors and provides us pretty safe environment to connect to our 220 volt AC from the wall sockets. Let's now look at detailed circuit for the working of a relay board. So now let's look at the circuit diagram that is actually implemented in the board. So we have a 12-volt supply where my mouse is right now, which is the 2 pins, which was the lowest pins to which we had connected our adapters. We're calling the positive 12 volts as VCC, and we're calling the ground as the ground, GND. We had the input pin. The positive of the input pin is connected to the base of the BC547 transistor. All the flags that you see as GND are interconnected. They're all the common ground. Now what happens is when I give a +1 to the input over here, the transistor acts as a closed switch, which is switched on, trying to switch on the appliance. This circuit between the ground, the coil of the relay, and VCC, this gets complete. So with the circuit being complete, it kind of triggers the relay and connects the output to the pin 3, which is the NO pin that we had connected our LED bulb to. So what we are doing is, AC has one is what is called the neutral pin and the other is called the live. You see the neutral of the AC input is connected to the neutral of the output directly. The input is connected to the pin 1 of the relay, and we have 2 pins in a relay, which is the NO pin, the pin 3, and the NC pin. So by default, when the relay is not triggered, the AC input, which is this to the pin 1, would get connected to this, the middle pin of the AC output, which means that if my input is 0, anything which is connected between pin 1 and pin 2 would be switched on, and anything connected between pin 1 and pin 3 would be switched off. And when I switch on and the relay is triggered and this metallic strip now connects 1 to pin 3, then anything connected between pin 1 and pin 2 of the output would be switched off. Anything connected between pin 1 and pin 3 of the output would be switched on. So if we want to go by the logical understanding of that we had always built, if my input is 0 and I want things to be switched off, I will connect it between pin 1 and pin 3 of my output. And if I similarly, when the output is 1, it's on, output is 0, it's off. So this is the circuit diagram for understanding how a relay works. I would also very quickly show you how did I get a 5 volt output and a 3.3 volt output. I have a VCC input which goes into a IC which is called 7805, a 5 volt regulator IC, which has 3 pins. One connects to the ground, one connects to the input voltage, in this case a 12 volt voltage, and I get an output of 5 volts. That is what the regulator IC does. Pretty simple. Similarly, there is another IC which is I'm using an SMD version of it. So this is the number of that IC. It takes again a VI as the input and gives me a V output of 3.3 regulated voltage irrespective of the input. In this case, I'm giving it the input of 5 volts, which is the output of 7805, and getting a regulated 3.3 voltage output. So these two outputs are used to power the sensors if I have to create a very small project that we would be doing in future also. Thank you very much for watching the video. In case you are interested in buying such boards from me, you can write to me at quiteeasily.done@hotmail.com. What I'm making is whatever projects that we would be working on, we'll be using such boards. You can create them at home also. In the advanced series, we would be talking about how to create these boards at home. But in case you want things to be easy in the starting, you can always mail to me and I can ship these things to you. Thank you so much.